Okay, so we are starting our new unit, which is about algebraic models. So basically with algebraic models, we did a lot of algebraic models in the geometry unit, okay, where you have a formula and then you're using the formula to solve for something. Either you're solving for a side, or if you're solving for a volume, or if you're solving, or if you're using the formula as is, or if you're rearranging the formula. So this is basically what we did. It's algebraic models, what we did also in the geometry. So if you think about formula, okay, the formula that you have been using, for example, for your geometry to find the surface area or the volume, what does it have inside of it? So volume of, let's say, a prism. Rectangular prism. V equals, you've used it, times W times H. What does it have in it? What does it have in that formula? Has letters, right? And there's some kind of operation happening between the letters. In this case, it's multiplication, right? And there's an equal sign. Yes? That's what a formula is. A formula is a mathematical equation. Equation means there is an equal sign right there, right? So that, when I have that equal sign, that representation. Okay? And then what I have is I have different variables that relate to each other somehow. Okay, in this case, they relate to each other by multiplying the length, the width, and the height to get the volume. Okay, if I have another formula, which is let's say B times H divided by 2, so that's the area of a triangle, right? Base times height divided by 2. Again, I'm relating area to the base to the height, and then I'm dividing by 2. So this is called a formula or a mathematical equation. That relates two or more variables. Okay, so we have one of the equations here, for example, P equals 25T minus 800. And this might give the profit from ticket sale, where P is the profit and T is the number of tickets sold. Okay, so I'm relating the profit to how many tickets I sell. There's a relation right there. Okay, or the Einstein theory of relativity, where the energy is equal to mc squared. Okay, this is also called a formula, or it's called algebraic relation. So you're going to be solving word problems, right, where I give you the formula, and then you're going to have to use the given information to solve for something in the formula. You either solve for let's say in the example of A equals BH over 2, I might give you the area and the base, and you have to solve for the height. Or I might give you the height and the area, and you have to solve for B. Or I might give you B and H, and you have to solve for A. So it depends on what's given to you and what you're looking for. You're going to have to rearrange your formula according to the opposite operation reverse BEDMAS. Okay? So always you have to follow a plan, okay? Look at what's given to you. Look at what you're looking to solve for, and then carry on with your plan. Sometimes you have to use more than one formula to be able to find your solution. Okay. Now, sometimes we also have to convert quantity, because remember that sometimes they give us let's say a side in meter, then another side in centimeter, and another side in millimeter, right? But we can't use the formula with different units. They have to have the same units in order for me to be able to find the area or the surface area or whatever it is, right? So sometimes I have to do some conversion. Now, let's look at an example here. So the formula S equals to 0.6t plus 331.5 gives the approximate speed of sound in air, where S in meters per second. So S is in meters per second, so that's the unit for it. And the temperature is in degree Celsius. Determine the speed of sound at negative 40 degrees Celsius. So you're going to start with the formula, right? What's the formula that's given to you? What's the formula that's given to you? S equals, 0.6t plus 331.5. So that's the formula that's given to me. I'm going to start with that. Now, what is given to you and what are you looking for? So what value did they give you in the question? I'm going to read the question again. Determine the speed of sound at negative 40 degrees Celsius. So what did they give me? The temperature. So they gave me T, right? So my given information is, I'm going to just ignore this, and I'm going to follow like a better system, which is the grasp system, okay? So the given information is T equal to negative 40 degrees Celsius. What is the question asking you to solve for? The speed of the sound, which is what letter? S. So the required S. That's what I'm looking for. Now my analysis, I've already written my analysis here at the beginning, so I don't have to rewrite it. Okay? So, given, required, analysis. Then I have to solve. When I'm solving, I'm substituting in whatever I know. Whatever information I know, I'm plugging it into the formula. So I know that T is negative 40 degrees Celsius. So that's going to be substituted in T in the formula. Yes? So in this case, S is equal to, so that's my solution. S is equal to 0.6 times negative 40. You don't need to include your units here. Plus 331.5. And then you're going to carry on this using your calculator. Now be careful when you're using your calculator, you have to follow bed math. So the first thing that you have to do is you have to multiply the 0.6 by the negative 40, and then you're going to add the 331.5. So what did you guys get? I got 307.5. Is that what you guys have? Huh? 0.6 times negative 40 is negative 24. And then if I add 331.5, it's going to be 307.5. And then this is my speed. What's the unit for speed? What does it say? What's the unit for speed? Huh? Meters per second. It gives you that in the question. So I know that my units here is meters per second. Yes? So I followed the grasp method by writing down the given information, the required information, write down the formula, which is the analysis, and then your solution. Okay? Now, the only thing that's missing is a therefore statement at the end. So therefore, the speed of sound is 307.5 meters per second. So what you guys have to always think about is this method of solving is not only for math. 90% of the time, I'm solving these questions, and these questions belong to physics, or belongs to chemistry, or belong to business, right? Math is only the method, right? So you're going to have to apply your knowledge that you learn here in math to solve problems when it comes to other courses. Okay? Either when you're doing construction, building, things like this. They're not math questions, right? But you're using the math in there to solve the problem. Are we okay with this method? All right. So let's read this question together. So we have a landscaper uses a bucket with radius 18 centimeter and a height of 18 centimeter to pour soil into a rectangular planter measuring 1.2 by 40 by 20, 1.2 meter by 40 centimeter by 20 centimeter. And the question is, how many buckets of soil are needed to fill the planter? So here is a landscaping question, right? Where landscapers need to know, right? Or, for example, my dad is in construction. He does all this calculation so he doesn't overbuy material because he doesn't want to lose money on, like, if he needs, let's say, 5 boxes of tile. If he buys 10, he wasted 5 boxes, right? So here's where we have to do the math again to be able to solve our problem. Okay? Now, what do we have here? What scenarios do we have? I have 2 shapes. Do you guys see the 2 shapes? Yes? So he has a bucket with radius 18 and a height of 18. So what shape is that? What is it? A cylinder, yeah. So you have a cylinder, right? And the cylinder is his bucket, right? His cylinder has a diameter of 18 centimeter and a height of 18 centimeter. Okay? Now he's going to fill that bucket and then he's going to dump it into a rectangular prism. Yes? The rectangular prism has the following dimensions. 1.2 meter by 40 centimeter by 20 centimeter. So what am I looking for in terms of, in order for me to be able to know how many buckets I need to fill? What am I comparing here? The volume of the bucket to the volume of the rectangular prism. And once I know the difference, I can find the ratio between the two, like divide them, right? So I know how many buckets I need. Yes? Okay, so here's my plan. My plan is to find the volume of the bucket, to find the volume of the rectangular prism, and then to divide the volume of the rectangular prism by the volume of the bucket so I know how many buckets I need. Does that make sense to you guys? So I read the question, I analyzed the question, and I put a plan to solve it. Now, so to find the volume of a cylinder, what's the formula? You guys still have your formula sheet, don't you? So pi r squared h. How about the volume of a rectangular prism? What's the formula? Length times width times height. Now I have a problem here though, right? If I look at the dimensions for the cylinder, they're both in centimeter, perfect, I have no issues. If I look at the dimensions for the rectangular prism, they're not all in centimeters. Okay? So I have 1 meter and then I have 2 centimeters. So I have to make them all the same. Because this is already in centimeter, the cylinder, right? So I have to make everything here in centimeter. So first I have to convert my length to centimeter. How can I convert meter to centimeter? Times it by 100, right? If you look at your pink, I don't know what color sheet I gave you, purple sheet I gave you. If you look there, it should be right there where meter to centimeter, but I also think about the meter sticks, right? If you think about the meter sticks that they used to use a long time ago at school, right? A meter stick is 100 centimeters. So this is kind of thing that you can remember, right? Yeah, so every 1 meter is equal to 100 centimeter. If I have 1.2 meter, so how many centimeters is that? 120, right? So remember the trick is you multiply and then you divide, right? But in this case, you're dividing by 1, so it's not going to change. So 1.2 meter times 100 centimeter per 1 meter, right? Which is going to cancel your meter, and then you're going to end up with 120 centimeter. Perfect. So I convert it, right? And I have everything in centimeter now. Now I can use my formulas to decide to find the volume. Okay? So I know that I'm going to have to find the volume of the planter, which is width times height. And I know that I have to find the volume of the bucket, which is pi r squared h. So now I'm going to substitute the given information. For the volume here, I have 120 centimeter by 40 by 20. So that's going to be 9,600 centimeter cube. And then for the volume of the cylinder, it's going to be pi. What's my radius? 9. Because the diameter is 18, so the radius is 9, and then times 18. So that's going to be pi times 9 squared times 18. So that's going to be 4,580. Did it say the diameter is 18? Oh, the radius is 18. I read diameter. I'm sorry. Then this picture is wrong. I read it as diameter. Thank you. So here, I drew the wrong picture. Thank you. So the radius is 18. Okay. And the height is 18. So I'm going to have to change this. And that's going to be 18 squared times 18. So that is 18. Something missing here. I'm missing something here. I think that's missing a 0, isn't it? Yeah, that's missing a 0. There you go. That's better. So that was supposed to be 96,996.
The second one is the height. The height
Is 18, and the radius is 18. That's what it says right here. It says that the radius is 18,
yeah.
height is 18. Okay, now, is the question done? Did I answer the question? Not yet, right? It's asking you how many buckets do you need. So what we have to do right now to find the number of buckets, I have to divide the volume of the planter by the volume of the bucket to find the number of buckets. And that's going to be 5.2. So when you say you're therefore, so you're going to say, that approximately, 5 buckets are needed to fill the planter. Does that make sense to you guys? Does it make sense? So what I want you to do is I want you to read the next question, okay? Come up with a way to solve it and share your solution with the person sitting next to you, okay? And let's see if you guys come up with different ideas, different ways to solve this problem. Do not worry about filling this out, okay? I just want you guys to solve it. Look at the way that you would solve it if you have a question like this.